Login accepted.
It's been a while since I've been on the stage, so pardon me if I feel awkward and moving around and things like that. Looks like the projector is working, which is a good thing because usually I have the slide that says your screen sharing is working, right? So that's what we were doing for the last year, and I'm super excited to be here and super excited that you all here. Who didn't have a coffee today? Okay, a few people. So you will have a hard time because it's going to be like a fast-paced presentation about like a lot of different things. And hopefully you will be able to catch up. At least you should have a water or something because there would be no stops. If you want to have any, if you have any questions or things like that, don't forget to find me afterwards. I really like to answer the question as they arrive. However, we have on a tight schedule, so I'm gladly answer all the questions and some enhanced and advanced interrogation afterward. Today we're going to be talking about a couple things. So we're going to be talking about the serverless in definition that I and my partner in crime who helped me develop this the presentation, James Ward, because sometimes people have opinions, and people have thoughts about how you should call certain things and how those things, what they actually mean. So I will explain that. And we talk about a couple things, how to using some of the cloud native and the serverless infrastructure to provision some data in Kafka, and how Kafka allows us to communicate some of the microservices. And we talk about some of the tricky parts around this, including the state management, for example, because it's all fun and games until you have a state and you need to manage state. And managing state in the cloud, it's quite challenging, I would say. All right, so what is serverless? What is serverless? It is something that people like to say it's, if it runs on someone else's computer, is it serverless? Like, because you're not owning the server, right? What I like to say is today we're going to be talking about the on-demand resource allocations in the cloud. So that might include some of the things that allows you to do some manual management. We're going to talk a little bit about Kubernetes. Something that allows you to do a little bit less management, like things like a fully serverless Kafka, or things that allows you to have a kind of like a mix and match with the Google Cloud Run, also known as Knative, which is kind of like Google Cloud Run implementation. So that's what we're going to be setting today, and there's going to be a lot of the live coding, not so many slides. I will use the slides only to set the stage. My name is Viktor Gamov, and I work as a developer advocate at a company called Kong. In Kong, we're doing all sorts of cloud connectivity stuff. If you're interested in stuff that I do have things. Please follow me on Twitter. I'm a very interesting person. I also co-author of upcoming mining book called Apache Kafka in Action, and only today, only here, you will get 35% discount if you will use this code. If you like, some people know how to find the literature in the internet these days. I'm not going to judge you. I'm doing this not for money, just because I want to share some expertise here. And there's a raffle for you. Like, if you will be here tweeting about this session, this is mentioned my Twitter handle and mentioning Devoxx Poland, there will be some prizes. We will do some prizes. We'll be doing some of the meetup after Devoxx, so there will be some swag and stuff. So go tweet about. And my Twitter handle conveniently placed on every slide. Okay, enough of this talk. So let's talk about serverless. What is a serverless? Essentially, the thing what I'm going to be telling you today, it's all about on-demand, like demand-driven infrastructure. A couple years ago, Jonas Bonner from Lightband posted very interesting, I don't remember, it was a tweet or it was a gist where he was explaining numbers that every software developer needs to know. Do you have any idea what I'm talking about? Like about latency, how the latency grows from processor to memory, from the memory to user space to network. How many of you have seen this article and like how these numbers are growing like exponentially? It was quite interesting discussions around those numbers. However, also a few years ago, CEO of the Confluent, he posted another tweet that says, those actual numbers that developers need to know these days, those numbers were actually prices for like cloud providers for different instances. So since we know right now, we're trying to solve some of the problems, and yeah, it's cool, we know all the latency numbers and how they grow from the processor registers to the point where you have a network, you have a disk, you have a distributed systems. But if you want to have a faster calculation these days, you just need to swipe credit card to get bigger instance, right? I don't know how many of you can relate, but this is the thing that many people just doing these days. Like, if there's not enough resources, that something is going wrong. Instead of doing this kind of like optimization stuff, investigating things, people just will be using like more hardware. And again, it's on demand. So once you don't need this, you will shut this down and you get the build only for what you use. So usage is important. So the many applications that we develop these days, they need to follow this like a 12-factor manifesto. Essentially, the applications, they don't own the state itself. They need to be configurable using the outside world, some of the environment variables. Those applications need to be, they don't need to share anything, so they can be scaled in the cloud environment during the Heroku days. And we still continue to developing this one. But like I said, it's all fun and games until you need to manage the state. And the things around stream processing, especially stream processing that requires you to do some stateful operation, like aggregations where you need to collect some of the results, would be somehow tricky to do if you not manage the state properly, and based on the usage and based on the usage pattern, how the people use this stuff. There's actually solutions that can solve this, and I'm going to be talking about this later today. Now, cloud is all about the pay what you use. Like I said, if you want to have a faster computation, you want your reports will finish faster, just get the, I don't know, like high mem machines or like mega mem machines, and just like knock yourself out. And internally inside the cloud providers, the way how it's implemented, those resources that will not be discarded, they will be like recycled. And some of the things that you use, you're not using anymore, they will return to this thing called cloud. And from that, someone else will allocate those resources for cloud providers. It allows them to stop things fast because they already have some pre-allocated hardware. So, like how you would measure, or like what you're paying for. Different the cloud providers provide different models. What you're paying for? You're paying for data, how much data you store. But you're paying for traffic, if it's something related to like load balancer, things like that. And all this usage, like all about paying only for what you use, not for this like pool of machines that allocated somewhere, just in case, because that's where the cloud infrastructure goes these days. I would like to introduce the term called the portable serverless that allows you not only to do things not only to do things in the cloud, but also you need to be productive on your development machine. In the good old days, I was doing a lot of demos in airports, airplanes, like automobiles and trains. So I couldn't do my cloud work when there's like a very bad connection. So I need to have a local environment that allows me to do this. And works on machine, hopefully also works on your CI/CD. How many of you use or heard about test containers? All right, few people. Oh, more people. Okay, so test containers, for those of you who don't know, like I would say eyeballing like 50% of the audience, it is a fantastic Java framework. It started as a Java framework, but there's test containers for different languages these days. It allows you for your integration tests using the JUnit as your kind of like a DSL to describing your integration test. Use real software instead of using mocks, instead of using I don't know, like for example, instead of using H2 for your test, you actually using real Oracle that comes in containers. Welcome to new generation. Oracle also comes in containers these days. And in this case, it allows you to have assurance that the stuff you're writing locally will be running somewhere where you're running your production code at the end of the day. So that was very useful when you have this ability to run the software. So not going to show you today, however, like code that includes this in this presentation. We'll have examples how we test this locally. We use the Kafka in the test container. We're going to be using KSQL DB also as part of the test containers. So we start this, we test these things, and we know that once we move to production, it also will work because it will be using same or at least similar infrastructure to do things. Kubernetes changed a lot in the way how we think about our own infrastructure. So no one doing the management, hopefully no one else doing like a management of the hardware themselves anymore, or there's some other tools. Let's pretend that like everyone is using Kubernetes. It would be much easier that if everyone was using Kubernetes, right? So because you will be able to, by defining your containers, your deployment descriptors, or maybe like Helm charts and things like that, you will be able to move between, this is portability, between clouds, between cloud providers, between your Kubernetes provider. Yes, of course, there is some of the vendor-specific things. The situation with Kubernetes these days reminds me situation with the Java EE containers, Java EE application servers, I don't know, 15 years ago, maybe. So there's multiple vendors to Kubernetes, multiple vendors of J2E servers. There are kind of sort of the specification that works everywhere. And there are tons of consultants, right? Like consultants are everywhere, like Kubernetes consultants and things like that. Do we have any Kubernetes consultants in the room? Like who say, I will do your Kubernetes for money? Anyone? No? Good. All right. So we have some people. How many of you actually run Kubernetes themselves, or run anything like OpenShift is also considered as a Kubernetes? Looks like I was told that OpenShift is big in Europe. So Kubernetes changed a lot in terms of portability, how we can move from one place to another. I prefer to do my stuff in the Google Cloud because they were kind of sort of introduced like the Kubernetes service, one of from the first cloud providers, and they still have the best experience in my opinion. Some other people will use Amazon, Azure, though I prefer just the Google Cloud. Now, the Kubernetes allows, like I said, as like a J2E back in the day, create some additional cool things on top of it. And some of the cool thing that was built on top of the Kubernetes was Knative. It's kind of like a framework that allows you to focus on applications, not the infrastructure, because Kubernetes is still kind of low-level thing. It allows you to do the stuff. There's the network configurations, you have containers, you have pods, you can do services, blah, 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 a lot of things. However, you want to deploy your app. You want to have your web app, your 12-factor app. You want to just like, ship it. And the cloud, the Knative provides this kind of ability. So Google Cloud Run, it's just the implementation or like their, version of Knative that allows you to deploy your app and don't need to worry about providing external access. You still can do this in Kubernetes, right? You can say, okay, so I have my app in a container, I will ship it, I will create the service, I'll create the ingress, I'll put some of the proxies in front of it and like do load balancing and stuff. Google Cloud Run makes it much, much easier. There's some limitations though, obviously, because of the nature of the system. However, still a very nice thing to do if you like. How many of you used Heroku before? Like, how many of you like this experience? I love this experience very much. I just specify my Git repository and I'll do Heroku push and that's it. My application is running. I don't do anything. So this experience, developer experience, was very much what the people in Kubernetes world want to adopt and bring this with the tools like the Cloud Run and Knative. So enough of the prelude. Let's talk about what I'm going to be showing you today. So I do have application that capture some of the popular questions in the Stack Overflow and store this data in a Google BigQuery. I'm not going to show you this part. However, one of the part is important. This application, this guy, so this URL, this stuff will be exposed outside world through WebSocket. So we're going to be using this WebSocket as some sort of like a generic input for my application. I need to bring some data to my Kafka server somehow. So it looks like it's a good example of streaming stuff. So there's some questions. I will capture those stream of those questions and put inside my Kafka. The next thing is that I will start to do some of the processing of this data on the fly. So doing things like filtering is not super exciting, simply because the filtering is stateless operation. You don't need to know the previous results in order to do filtering, and it's quite trivial. You just have a predicate that says, okay, if this something is true, we will create new stream. If not, we will discard it. However, when we go into the world of the stateful stream processing, the application, like simple summing, if you need to just have some count of the how many messages you have, right? You need to store the state somewhere. So that's going to be stateful operation. We're going to be using this serverless platform called KSQLDB that allows me to kind of deploy SQL-like queries that will be essentially my Lambda expression that will running somewhere in the cloud. And as a result, we also will have some of the application that will be deployed on a Google Cloud Run, and this application will be pushing the data from this KSQLDB, this cloud native stream processing database. All right. So 3 things: capturing data, capturing changes that coming from somewhere, in this case Stack Overflow, doing some processing, and getting the results of this processing into the into our UI. So what I'm going to be using today, what kind of tools you need if you want to play this around. Google Cloud, Confluent Cloud, which is going to be like serverless Kafka, JQ, which is the fantastic tool for parsing JSON, and Spring Boot. I didn't put the Kotlin because Kotlin was in the title, and I think this is also a very important slide. If you want to have this stuff running on your infrastructure, it's a good time. Take the picture, tweet this picture, and you know what to do, right? So this guy, so do it. All right. Let's take a look. What do we have here? So if you will go into this repository, you will get a couple projects here. First of all, we start with this project called WS2Kafka. So essentially, it is an application that will using a WebSocket client that also comes with Spring Boot. And by the way, everyone can read Kotlin? Like, how many of you Kotlin developers here? Java developers. So cool thing about the Kotlin and Java developers, even though it is written in Kotlin, Java developers can understand. How many Scala developers we have here? So there's a difference between the Scala developers and Kotlin developers. Even when the Scala developers write the code, not many Scala developers will understand this code. It's totally different with Kotlin. So Kotlin is much more readable. It was a joke. That's why I was asking earlier if you have a coffee enough, so you will be able to, consume some of the programmers humor. No? All right. So never mind. So yeah, I'll try it. Okay. I'll just be ready. There will be more humor. So a couple things here. So we do have this the service, and if I will show you, I love when the IntelliJ IDEA does that. It's actually pretty nice. So if I will go here, this application is actually deployed in Google Cloud Run itself. So we go in here, and this is how it looks like. There would be some of the time where, no, it's actually already up and running. It looks like someone is triggering this. So those questions coming somewhere. So I want to capture this, and now I want to see these captures, want to see these questions in my Kafka topic. So how I would do this, in this application, what I will do is just getting this question. I will read this as a JSON, and the Kotlin has this like a fantastic feature. Like everyone who's talking Kotlin cannot talk about cannot not talk about data classes, because data classes is awesome. So we have a question that's data class question that works very well with Jackson, and we can turn this JSON that comes from this WebSocket. What we can see here, if I go in my console, let me do a quick refresh. I'll show you how this JSON looks like. Go in network, we do WC, and the messages look something like this. You know, some JSON, there's some body, some tags, some title. So this type of stuff that coming into my system. And I will parse this and turn this into Java object. Why? That's a very good question. Like, why not push this directly? So I don't know how many of you have been in a presentation of my former colleague Tim Berlin yesterday when he was talking about how not to do event-driven architecture, and he also pointed out, think about the schema. You know, essentially when you're pushing something to Kafka, Kafka really doesn't care what you put in there. How many of you actually push some of the images to Kafka? No, good people in the room. It's good. Some people actually pushing images to Kafka, because Kafka doesn't care. Kafka stores bytes, and that's it. Kafka don't care what you're putting there. There's some of the implication in terms of size of this object, but really doesn't matter. But you as a developers or colleagues, you care about the structure of your data. When you're reading this, you want to make sure you understand what is coming there. In the world of these modern microservices, we write these microservices in whatever language we can hire programmers, right? The programmers know different languages, and we want to have something that they can exchange this information. And the Java bytes, like Java objects, maybe not very good example of something that is very portable. So that's why people come up with something cooler, like a protobuf, for example, or JSON schema, or Avro if you're in kind of like in the big data in the Hadoop world. Welcome, you can see just plenty of spaces here to down. We're going to be using schema, JSON schema here, because it's easy, and more importantly, this schema will be stored in a place called schema registry. So the next application, in my case, my cloud native blah 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 database called KSQLDB, will be using this schema in order to introspect this data. And it will using this automatically, so I don't need to provide the schema when I'm writing my query. So I will show you this in a second. And since it works with the JSON and this serializer that will be reading this JSON, writing to Kafka, can extract this JSON schema and publish this in schema registry. Next thing is that, there's no next thing, that's it. So we're reading the message from the stream, turn this JSON into object, and after that we're pushing this into Kafka and pushing to schema registry. So let's run this real quick and see if it works. So for my deployment, let me check my note. Yes, okay. So I will be using this small tool called Scaffold. Scaffold is it's kind of like a small like a watcher that runs in your on your development machine, and after that update some of the resources that happen on your machine into the Kubernetes cluster. You can do something similar with kubeapply and file, but like in this case, the Scaffold does a very good thing for me. It also clean up after some of the work that I do. So I'll do Scaffold dev. So in this case, what Scaffold will do for me, there's a Scaffold file, and it will pick up secret that will include some of the keys and API keys and secrets for my application to connect to Confluent Cloud, and which I will show in a second. And what do we have here? So this is the terminal. This is a very cool tool called K9s. If you're developing anything in Kubernetes, I highly recommend you start using this today. It's just like awesome. Because it allows me to do things like, okay, so I just went into my Kubernetes cluster, drilled down into my pod, and now I see what is happening on my pod. So those questions that you see on the screen now landing in the Kafka topic. How I can see this? So when I go to Confluent Cloud, I go to topic. There's my topic. I'm super, unique with the names of my topic. And all these messages right now are streamed to Kafka. I think it will, will get some of the round of applause because I think it's pretty exciting. I just show you how you can bring this stuff from the WebSocket into Kafka in a few seconds. No applause. Thank you. So that's good. Yes. We will, do this more in future. So speaking about the schema, so we can introspect our topic and see that our topic right now includes this object that includes a schema, and we see this is it is a JSON schema. Like I mentioned, JSON schema. Like I mentioned in a few seconds ago, protobuf and Avro is also supported. This case, I see that schema object include, and there's a bunch of stuff here. There's a body, there's a count, there's tags, title, URL, and the view count. The same information that we're getting from this guy. So we were able to get this from our JSON and put this in Kafka, and we can introspect those. Now we can see what is going on here and things like that. So let me let me stop this for a second. We'll get back to this one. Now, next thing is that we're talking about the processing stuff. How are we gonna process stuff? How many of you heard about the Kafka Streams? Like a half. Okay, so the Kafka Streams is a Java or JVM library because there's API for Scala. There's native API for Scala as well that allows you to write stream processing applications, not the stream processing clusters that you do with Spark, for example. You actually writing your application because Kafka Streams, it is a library. So you put this library inside your application using Spring Boot and just deploy this. I will be talking about Kafka Streams in more detail later today. If you're interested in this type of jazz, stop by around 4 o'clock. There will be more Spring Boot and Kafka Streams there. So Kafka Streams provides, like I said, Java API and provides the Scala API. However, there are some people who think, okay, so I'm a cloud developer. I don't care about where you run my Java. I don't care about Java at all. I want to have something like Amazon Lambda, but for my stream processing. So this is where the KSQL DB comes into play. It's like a freely available. You can run this ksqldb.io website, and you can grab this KSQL DB thingy. But there's also like a fully serverless KSQL DB thing. And this KSQL DB thing, we're gonna be doing. Where is it? KSQL DB setup. This is how your application will look from now on. So essentially, it is my Spring Boot application using Kotlin, and in this case, it will be talking to my KSQL DB server through KSQL DB endpoint. And let me show you quickly. So if I will do make cloud validate. So some of the things that I do have here, it's the endpoint. And it is, as a matter of fact, is the kind of REST-like endpoint. It's actually HTTP2 endpoint, and it's more like RPC-like style of communication, but it is still endpoint that you will be able to hit from your application. There is the wrapper that I wrote for this that also allows to execute different statements. And this is how I will provision my streams in my KSQL DB. So first thing here, I want to create a stream that called Stack Overflow. So what the stream will do, it will take the data from my Kafka topic, take information from the scheme registry, and turn it into something that I can work with, in something that's turned bytes into the things that I can work with. In this case, it creates a stream called Stack Overflow. From this stream, I want to create another one that I will will have a count of a particular question. So I'll have a question for Java, and there would be count of those. I would be having question about for this one I'm lying. So for this one I'll have a total count of the questions. So I'll be aggregating number of messages that I will be receiving from this endpoint. So for the next thing is here, I will be doing some of the parsing. So in my where's my main question.kt. So question.kt has a list of tags, and I want to have probably, the Scala people will call it sort of like a flat map, right? Where you have a list of something and you want to produce another stream, or maybe Java people also call it flat map or things like that. In the database world, guess how they call it? Explode. They will explode. So that's what basically, that's how we that's how it should be called in Scala, because Scala as a name, it sounds cool, much cooler than, I don't know, Lua, for example. In this case, the explode will take the list of this from the input stream. We will produce another stream that each element of the stream will include question and a particular tag. Why are we doing this? Because we want to aggregate in future for particular tag. In order to get this, we need to have the stream that will be will include additional information about it. And this is where we're going into the stateful operation. So in this particular case, this table will have an aggregate. In this particular case, it will be aggregated by tags. How many questions we have for Java? How many questions we have for JavaScript and stuff like that. And after that, we also will do another aggregation. So what this application will do in this particular case, it will start, create those streams somewhere in the cloud, and will die. So that's the only thing that this application will do. So let me consult with my README and how to run this application. Okay, so be set up and should be good to go. So it will use my environment variables just to provision. So I will be using this only to provision this stream. This exception here on purpose so I can bring your attention. I don't know, it's actually Native throws this exception because on the Mac it uses this like DNS resolver. My application actually fine, it's nothing to do with my application, but will get your attention. This is another annoying thing that's like when I'm doing some of the presentation, I just decide to, okay, maybe it's not secured, so let me log you out. So I need to get back to the screen. All right, so when I go to my KSQLDB app, what I will see here. So I will see let me actually show you this, because it will have a visual representation of the things, what is going on here. So there's my topic. That includes information from the Stack Overflow. And now this topic become a stream. See, those data now is parsed, and all these fields from this stream is now available for me, like you do in your database, right? You can do like where clause and things like that. So this is what you know what? Let me do this one more time. I will bring back the application that will be pumping data in, so we will see that stream is actually alive, and data comes into Kafka. We'll start in 3, 2, 1, go. Come on. You're embarrassing me. Come on. Okay, so let's see if my application is running. Okay, still running. Questions here. Let me do this one. All right, so now you see the data is alive, and what's happening, data comes from this WebSocket application into Kafka topic. From the Kafka topic, this KSQLDB will parse it and will generate this stream based on the schema that it was introspected. As you can see here, in my query that I showed you here, I don't specify any field, and I'm not telling the SQLDB how to parse particular JSON. I can, but why I should do this if I will just specify this the value format. Based on the value format, this SQLDB file will go to my schema registry and will find information, whatever is required. So that's why I was able to parse it. From here, we'll have two streams. Remember, I put these two queries: create the stream tags and create a stream stacker flow all. So let's take a look here. So what is going on here? Now the let's introspect, because we will be able to see what do we have here. Now, as you can see here, tag. So tag right now, not at least it's just a tag. So now we will be able to do some sort of some aggregation. And with this guy, I can create a table. That's my statement that I just created, and I will be able to see some of the questions here. And now, this is aggregation that is happening right now for particular tag, and I'm also doing a running count. You can ask the question, Victor, but like you're talking about state, where the state is stored, right? So the state of this computation is actually stored in Kafka. So the SQLDB, Kafka Streams, those two frameworks that exist, and they use Kafka not only as a source of data or as a destination for your data, but also it uses Kafka as a storage for the stuff that they need. So if we will do some sort of aggregation and we need to store intermediate results somewhere, it's actually stored in the special Kafka topics that that will be used for, in case of application will die. The application will die, the state will be gone, but Kafka has a state. And there's, the Kafka is running, so when the Kafka dies, everything is bad, right? So you cannot do anything. But once the Kafka is running, and it's running on the infrastructure, so this calculation will continue to do. So that's essentially your. Let me show you. Those streams are up and running. So those streams are continuously running in infrastructure. They will cost money because it will be running somewhere and on someone else's server, right? So. But you're paying only for your computation. Like if you don't need this, you shut down this application, you're done. You calculate your result, your report, you're doing this report once in a month. You pull this up, you have this data, you run this for like 2 hours, 3 hours, 4 hours, and after that, shut down, you swipe the credit card, you're done, right? That's the beauty of this one. And again, since the data is stored inside the Kafka will cost you from perspective of storage. So in this case, like if you want to store indefinitely all your data, you can. It will be just a different price tag. And the Kafka storage, relatively cheap comparing to computation price. And the results also will be stored in Kafka. Now, you might ask a question. Okay, so you showed us nice UI. Like, I want to have this data in my application. I want to have this in my dashboard. How I can do this? So the third part that I will be showing you today, it is my application that now I will be deploying into Google Cloud Run. So we will get these results. Let me quickly show you what this application will do. We call it Web UI. And the cool thing about the once you start using Kotlin, you stop writing HTML by hand because Kotlin has HTML DSL. So I present you Kotlin-based HTML that essentially does whatever your HTML editor gives you. You can have like a highlight of certain tags. It's a type safe as well, and you can do stuff. So I have a head, I have body. I have different divs here. I can modify this. I can bring my favorite templating engine, and that will just do the thing. So what we can do here, only thing that this application will use, it uses this SQLDB reactive client that will connect to this endpoint. And from this endpoint, it will just reading this data based on this particular query. So this is query that we want to calculate. And we will get these numbers here. So in order to deploy this, how it's called? Okay. Yep. So we will call it. So let me kill this one real quick. And deploy KSQL app. While it will doing this thing, I will tell you what it actually does. So it will be using these. Let me see if it will just do another build. Neat part, the Spring Boot comes with the tools that allow you to build the images. So that's fantastic. I don't know why I'm doing this right now. Hopefully the internet is fast enough in order to push it. But that's, I guess, how my scripts were configured. So my Google Cloud run, the G Cloud has this command run that will take the arbitrary Docker image so we can run. You can ask, Victor, but why we need to go through this route with the running the app separately and stream processing on the thing? Why we cannot run the same stream processing inside the Google Cloud Run? In the beginning of my talk, I was talking a little bit about some of the limitations that some of those technologies have, and that these limitations also were available in Heroku, for example. You can, for example, only hit HTTP endpoint or expose HTTP endpoint. Kafka protocol is binary protocol. It runs on top of the L4 protocol, so it is a TCP/IP protocol. Those things are not available in Cloud Run environments. So let me actually show something that will be more exciting than looking into my console. We're gonna look how the application will be deployed, which is also cool. So that's why we need to have something that allows to bring, first of all, there's no state here because it's an arbitrary Docker. I need to store state somewhere. So my state now in KSQL, and here in my application, I just want to have a dashboard that will display. Cool thing about this in a Google Cloud Run is that you will be able to get this. You see this URL that we will hit in a second. You can also open this in your in a phone. You will see the result of this application. So this URL will be provided us automatically. So I didn't set up any load balancers. It was happening for me from the Google side of things. So let's take a look how my application looks like. Again, remember, it's an on-demand loading. So first time will take a few seconds to start up because it was deployed, but it's in this crowd thing. So now it will bring this up. Now what we see here, we have this the serverless thing. And we have this information now coming from KSQL. We're creating this KSQL. Let me just show you the WebSocket that reads this data from languages. We got this. KSQL supports continuous queries, so the data will be continuously pushing through this HTTP2 connection. Also, KSQL supports the so-called pull queries, the traditional SQL queries, right? You can do issue query and get the result immediately. So this is how we get this a total count, which is when they load the page, we read this data through this query, and after that, all these results coming here as the WebSocket result, and as a aggregated thingy that we created in our KSQL. Why it is not changing, you might ask. You will be correct, because I killed my application that will be constantly pumping this data in. So let's see. So we'll see topic, my topic. Where's my? Well, there should be, yeah. So there's nice UI. So in this particular case, there's the producer one. It's my application that writes data in this topic, and after that, it will be consumed by multiple streams. So one stream was created to create the all Stack Overflow things, and another one is stream that includes a tag. So that's my application. That's something is running in a serverless environment. without me. And now my application is actually only getting some results. Now they see the time, the things that changed. So for example, let me show you. Java. So let's take a look on the Java and see if this will change over the time. I hope there's some people asking questions about the Java. Now you see it's a 34. So this thing is constantly changing to this one. So if I will drill down here, I will get the questions for Java that also coming from KSQLDB. So based on this tag, we were able to extract only Java questions. So now tag is our only one piece of the query that we need to execute. To recap what we just saw here. So you still, in the world of modern software, you cannot avoid not to use something that use something different than HTTP protocol. So that's why we still need to have things like Kubernetes that allows you to run pretty much any type of workload. So I was reading data from WebSocket and pushing data to Kafka, and it's running inside the Kubernetes. Next thing is that if I want to do processing, I can write my application and run this in Kubernetes as well, and also will be fine. My Kafka Streams application will be running the same. Like amount of work that I need to do here would be substantially more because I need to write the code. Or I can use the tools like KSQLDB using SQL. There's like a good thing that you had to write less code. Bad thing you had to write SQL. But there's a tools that allows you to make like a less painful. And more importantly, like serverless Kafka somewhere in the cloud, someone else managed, and that you know that you don't need to manage yourself, and know that there would be infinite storage, you know that there would be infinite retention of your data, and you know that it will cost you, something, but not, you don't need to rob the bank to run this. That will be like a big, and your application can use this data because Kafka remembers all this kind of stuff. And including the things that we were processing. Results also stored there. And for like simple workload, like my application that reads data from Stack Overflow, that reads data from the BigQuery, and send this through the WebSocket, that's my Cloud Run application. Or application that will use the similar approach, but for streaming database called KSQLDB. Also will be deployed in Google Cloud Run, and it will be running there. I can scale this if I see the load will be increased, so I can do this fairly quickly. And the neat part, you get to use whatever tools that you like. You can use language of your choice, and I like to use Kotlin more and more because of, when the last time you wrote the HTML not in HTML, right? It was a joke. All right, so tough crowd. Couple things. So I will be doing some of the meetup later today. I will be doing another talk about Kafka Streams, Spring Boot, a little bit more Kubernetes stuff, more Spring Boot, more Spring Cloud Streams. If you're in this type of jazz, I welcome you to join me. With this, my name is Viktor Gamov, and as always, have a nice day. I do have a 1 minute, 30 seconds until the end, and I'll take one question. And after that, you can find me afterwards, and I will answer all your questions if you have. And now the light's on, and people are like, okay, so what is going on here? I was just sleeping all the time. Any questions? I understand sometimes it's a very difficult to ask the questions when the other people are looking. You can always find me. I will be wearing this t-shirt all day. If you have any questions about Kafka, I'll be around. Thank you.